Okay, so starting back up with this example, so what they want us to do is to show that the error or the vector from R to S is equivalent to the vector from P to Q. Now remember, for two vectors to be equivalent, they have to have the same magnitude, which is the length, and they have to be going in the same direction. So just taking a look at R, S, and at PQ, those two vectors, they are pointing in the same direction, so they are moving in the same direction. So we know that that's true. Okay, if that wasn't true, then we couldn't prove that they were equivalent. Alright, so before we can find the magnitude, you have to actually find the vector. So R, the coordinate for R is -4, 2, and the coordinate for S is -1, 6. Okay, it's kind of hard to see in the picture, but starts at R, ends at S. So if you want to find the actual vector for RS, you're going to be doing the S minus R point. So -1 minus -4, and then 6 minus 2. So my vector for RS is going to be 3, 4. Okay, so then I'm going to go ahead and find the vector for PQ. So P is 2, -1, and Q is 5, 3. So to find our vector for PQ, we're going to be doing the Q point minus P. So 5 minus 2 and 3 minus -1. So my vector for PQ is going to be 3, 4. So they do have the same vectors, so they should have the same magnitude, but we just need to show it, okay, because part of showing that they're equivalent is showing they have the same direction and same magnitude. So if we find the magnitude of RS, it's the square root, it's your x value, so 3 squared plus 4 squared. So we'll have the square root of 9 plus 16, so the square root of 25, which is 5. And then if I find the magnitude of PQ, square root of 3 squared plus 4 squared, which is also the square root of 25, which is 5. So they also have the same magnitude. So because these were pointing in the same direction and had the same magnitude, we can say these are equivalent, and they're calling them arrows there, but we can say they're equivalent vectors. Okay. So once again, a couple things that you need to know so far. So vectors is just a lot of little specific things. So it's like array. So a vector starts at a certain point, so the initial, and goes to the terminal. So it goes from R to S. So it should start at R and end at S, since that's where the arrow is. When you have two ordered pairs and you're trying to find the vector, you're always subtracting the part at the arrow minus the part where it starts. So the terminal minus initial. So in this case, S minus R. This tells you the vector. Okay, so the vector is 3, 4, x value 3, y value 4. If you put these absolute value bars around the vector, that means you want to find the magnitude. Magnitude tells you the length. And to do that is the square root of a squared plus b squared, and that gives you the magnitude. Okay? Alright, a few more examples of this. So for this next one, so for the first example here, it says an arrow. So guys, when it says arrow, just think about a vector. It has an initial point at 3, 5. So that's where it starts. Okay. Don't think about it that way. And then the vector is -3, 6. We need to find what the terminal point is. Okay, so I'm going to call my terminal point x2, y2. And if you don't want to use the x, like, let's just call it x and y, because that's what we're missing. Maybe that'll make. So I'm looking for x, y here, that ordered pair. So this is my initial. I'm missing my terminal, but I do know what my vector is. Okay? So think about how you would find a vector. To find a vector, you do the terminal minus the initial. So if you're going to set this up, you would do x minus 3 for your x value. And then terminal minus initial would be y minus 5. And we already know the answer to this. The vector answer should be -3, 6. So you're just going to set up little equations. We know x minus 3 has to be equal to negative 3, which means that x value has to be 0. And then we know y minus 5 has to be equal to 6. So y would have to be 11. So my terminal point that would make that have that vector is the point 0, 11. So you're just working backwards there. Okay? So for the second one, it's very similar. So for the second one, Q is the point 4, negative 3. We're working with the vector PQ. So just from this written this way, we know that P is where it starts, Q is where it ends. We just said that Q is 4, negative 3. The vector that it represents is negative 2, 4. We want to find what the ordered pair for P is. So I'm going to do the same thing. I'm going to call just P, X, Y, because that's what I'm looking for. And we know the vector. So if we were going to write the vector, we always do the terminal minus the initial. So we would be doing 4 minus X this time, comma. Then we would be doing negative 3 minus Y. So that's how you would set up the vector. We know the vector is negative 2, 4. So we know 4 minus x has to be equal to negative 2. Only thing I have to be careful about is because it's the negative x. So if I subtract over 4, we'll have negative x equals negative 6. So x is going to be positive 6. And then we know negative 3 minus y has to be equal to 4. So if we add over the 3, we'll have 7. So y is equal to negative 7. So the point for P is 6, negative 7. So just working backwards, making sure you understand the head minus tail rule, and that you can write a vector. Right. Okay, adding vectors or subtracting vectors and the product of a scalar with a vector. So super easy here. Okay, so it says up here at the top, if you have a vector u plus a vector v, what you're going to do is you're going to add your x values from the u and the v, and that will be your new x coordinate of your vector. And then you're going to add your y values of your u and v, and that will be your y values. So you're just adding the values together. For the scalar multiplication here, so there's just saying if you have like 3 times the vector out front, you're just going to multiply the x and the y values by that 3, or whatever that k is. Okay? So let's see how this works. So for these problems, we're using the vector u as negative 1, 5, and the vector v is 2, negative 3. Okay, so number 1, we want to add the vector u plus the vector v. Okay? Now I want to make mention of something. These could have little vector things over them, or because they've already told you that it's in this notation, you know that those are vectors. So it doesn't have to have the vector over it, u plus v. So if we want to add u plus v, what you're going to do is you're going to take your u, I'm going to write it out, negative 1, 5 plus your v. So it would look like that. So to get your what's called a resultant vector, you're going to add your x value, so negative 1 plus 2. And then you're going to add your y values, 5 plus negative 3. So my resultant vector is going to be 1, 2. So this would be my vector that results from adding those two vectors together. So all you're doing is adding your x's, adding your y's. So for number 2, we have negative 4 times the vector u. So this is negative 4 times my vector u, which was negative 1, 5. So in order to do this, you are just multiplying this negative 4 times the negative 1, which will make it positive 4, and then negative 4 times the 5, which will make it negative 20. Okay, if you don't want to think about it as distributing, you can do like negative 4 times negative 1, and negative 4 times 5 is essentially what we did there. Okay? And then if you take a look at the third one, this one we have 2u minus 3v. So let's get this set up. We have 2 times our u vector minus 3 times our v vector. Okay, so I'm going to go ahead and do the scalar part first. So if I distribute this 2, we'll have a vector with -2, 10. Now, it's up to you, but I like to change this to plus and just make this a -3. So I'm going to put plus in the middle. I'm going to distribute a -3. So in my vector, I'm going to have -6 and +9. This way, now I can just add the vectors and I don't have to worry about subtraction. So -2 plus -6 will give me -8. And 10 plus 9 will give me 19. So my resultant vector from that is -8, 19. And then for the last part here, they ask for the absolute value of v and the absolute value of u. So guys, remember, that doesn't really mean the absolute value in this case. For vectors, that means we want to find the magnitude. So if we find the magnitude of v, first off, v is 2, -3. So for the magnitude, it would be the square root of 2 squared plus -3 squared. So the square root of 4 plus 9 is the square root of 13. And then if we find the magnitude of u, so u is the -125 is the vector. So it'll be the square root of -1 squared plus 5 squared. So the square root of 1 plus 25 is the square root of 26. Okay, so that is how you multiply a scalar out front. You just distribute it in, or you can add or subtract your two vectors just by adding or subtracting the x and the y coordinates. And then we also can find the magnitude when it has that absolute value. And then just to kind of look at what we just did, because we don't get to spend a whole lot of time on this, we don't look at this a whole lot, but when you're adding two vectors, so if I had a vector u and a vector v, when you add them together, it's like you're taking one vector and you're placing it at the tip of the other vector. So when you add those two vectors together, the resultant vector is the vector that it makes once you add those two together. Okay. Or another way to look at it, if you have put u, v here, so you didn't stack them on top of each other, but you could draw the other one here, it would get you to what the resultant vector is. Okay, so just kind of a graphical way to look at what you're doing when you're adding. Now the scalar makes sense. If you had u and you double it, it should be twice as long. Okay, if you half it, it should be half as long. If you multiply it by a negative, so if we have 2u and you multiply it by a negative 2u, it should be the same vector, it should just be going the opposite direction. So this is just kind of graphically what's happening, what we did on the last example.